So we started the discussion related to continuous random variables this today. I hope you have watched the videos, and I'll go through one or two examples. Okay, so we talked about discrete and continuous random variables, right? Discrete random variables. Those are the ones where we can count how many possible values they get. We can exactly count what are those possible values and so forth, right? And then on the other hand, we also have continuous random variables. Where they can get any possible value in the range of the numbers that we have. For example, if I tell you X is a discrete random variable, and the possible values that it gets goes everywhere from 4, let's say, to 15, let's say. Okay, so in this scenario, let me actually make it a little smaller so we can it can go everywhere from 4 to 10. Okay, so and let's say 4 and 10 are included in this range. So in that scenario, can you tell me exactly how many numbers this random variable can get? Can you count them for me? Exactly, 4, 5, 6, 7, 8, 9, 10. Okay, those are possible values. If I tell you, and as you can see, we not only can count those numbers, but they are discrete, like it's 4, 5, 6, 7. There's no 4.5, 4.03 or nothing like that. Also, if I tell you the random variable X is a discrete random variable and can get any values, let's say greater than 4, 5, all the way to infinity. Is this also a discrete random variable still? For the definition of discrete random variables, what is important is that we can count them. It's okay if there are infinite number of them. That's perfectly fine. So as long as I can count, I can say 4, 5, 6, 7, like I can count them. That's all I need. If there are infinite of them, that's perfectly fine. If there is a random variable X that can get all the discrete numbers from minus infinity to plus infinity, that's still a discrete random variable. It's okay if there are infinite possible values, but you can count them if you want to. Okay, so for the discrete random variables, then the main things is we can count them. And it's okay if the range goes to infinity. That's perfectly fine. But for the continuous random variables, we cannot count them. If I tell you y, let's say, is a continuous random variable, and it takes values between 4 to 10. Can you tell me how many numbers are between 4 to 10? They're continuous, like not just integers. Because when I say continuous numbers between 4 to 10, I mean 4, 4.01, I don't know, 4.001, 4.0001, like all the way, like just you name it, whatever digits you can come up with, those are all in this range. When we talk about continuous random variables between 4 and 10, all these possible decimal points, they are in there. You can't even count them. You can't even tell how many are there. It's impossible even to count them. Okay, so there are infinite number between 4 to 10, but you cannot count them. So that's the definition of continuous random variables. We cannot count those numbers. They're just, you just consider, as I said, all possible combination of decimal points and so forth. They're all in this range for this random variable. So we cannot count number of continuous random variables that are in this range. And because of that, it's continuous random variable. Okay. So that's the main difference between the two. One, you can count them, that's discrete. And then if you cannot count them, those are continuous random variables. Now, For the discrete random variable, we had probability mass function, right? Or PMF. And that's the one that we showed with f of x, or probability that x get value of x. For discrete random variables, we have probability density function, or PDF. And we still show it with f of x, but I no longer can write it as in this way. I cannot write it in this way anymore. That's our probability density function. So what I said was that for the probability density function, I no longer can write it in this way. I no longer can write it in this way that I have here. And let's see why. So in a probability mass function, okay, so let's write it here in the discrete scenario, and this is continuous scenario. So in a discrete scenario, the same example, x varies between 4 to 10. Can I write what is probability that x is 5? If I write that, there is answer to this question. You can calculate the answer depending on how do you write the probability mass function. You can find the answer to this question. But for the continuous random variable, the same variable as y, which is between 4 to 10, then if I tell you what is probability that y is exactly 5, the answer, what is the answer to this question?
Infinity.
0.
It's 0. So what happens is that I tell you there are infinite numbers in this range, infinite possible numbers in this range. Now, what is the chance that I pick a number and it's exactly 5? It's just almost 0. There's so many numbers in this range that the fact that you come up with exactly 5 is so small, almost 0. We can look at probabilities in the range of 5 or close to 5, in the vicinity of 5. If it's 5, okay, it's in the vicinity of 5. We can calculate those probabilities, but exactly 5, it's 0. Because of that, in the discrete scenario, I can tell you, for example, what is probability of x greater than, let's say, 6. And I can also tell you probability of x greater than or equal to 6, okay? Are these two probabilities different in a discrete random variable? If I calculate them, do you expect to get different numbers for these?
It should be different.
Because of this equality. One of them is anything greater than 6, 7, 8, 9, 10. One of them is anything. Do you hear me, guys?
The probability of 7, 8, 9, 10, and the other one, the 6 is included.
Exactly. So these two will be different for discrete random variables. However, in a continuous scenario, if I ask these two questions, do you expect them to be the same or different?
Same, because the probability of 6 is 0.
Exactly, because probability of x equal to 6 is 0. So these two are equal for a continuous random variable. So in a continuous random variables, if I ask you, for example, what is probability that y, I'm sorry, that means y. If I ask you, for example, what is the probability that y is between 5 and 8? This is the same as me writing it this way. The same as and the same as. They're all the same. No matter if you put the equality sign or not, the equality doesn't matter. In the continuous random variables, for continuous random variables, equal to something is 0. But if it's a discrete random variable, then yes, they are not the same. It's not the same as. It's not the same as. It's not the same as this. They're not the same. Where you put the equality matters for the discrete random variable. Okay. So just keep that in mind. But the other definitions that, okay, the probability mass function or the probability density function, still we want them to be greater than or equal to 0. So probability mass function or probability density function, still we want them to be greater than or equal to 0 for all x. And we want also, if it's a probability mass function, we want the sum of those probabilities. And if it's a probability density function, we want the integral or the sum again of those probabilities to be 1. They hold for both scenarios. So if you get a probability mass function or get a probability density function and you want to check if they are valid functions, you can still check both these rules. Okay, let's look at one example. Okay, let's assume I have a continuous random variable x is a continuous random variable, and f of x, probability mass function, probability density function, is at 0.1 x minus 0.1 x. Okay, and let's assume x goes from everywhere from infinity to plus infinity. Now, I ask you, what is the probability that we have a random variable? What is probability that this random variable is greater than 50? The probability that the random variable is greater than 50. How do you calculate that?
The integration of the function from 50 to infinity.
From 50 to infinity, and this is the function. Okay, I'm not going to calculate the integral for you, but that's all you need to calculate. Greater than 50 means going from 50 all the way to infinity. The reason all the way to infinity is that the upper bound is infinity. Lower bound is minus infinity, but we want to know greater than 50, that's 50. So if I tell you what is the probability that the random variable x is at least 50, how do you write that? Probability of x at least 50.
Greater than or equal to 50.
Greater than or equal to 50. At least 50 means it's 50 and anything above. Now, would this probability be any different from what we calculated on the top?
They should be same.
They are the same. Because we said this equality sign does not matter at all. Still, if you want to calculate this probability, you have to come and look at this. That's the same. So probability of x greater than 50 and x greater than or equal to 50, they are the same. If I ask you, what is the probability that x is between 25 and 60? Oops. I put the equality sign for 25, but not for the 60. How do you calculate this?
You just change the bounds from the upper bound is 60 and lower bound 25.
Yeah, exactly. And then the rest, f of x dx.
It should be equal to 1, right?
No, this should not, because it's equal to 1 in this range from minus infinity to plus infinity. So in this range, which is just a subset of the actual range, it should be something less than 1. It may be close to 1, but it should be something less than 1 for sure. If I calculate f of x from the start of the x to the end of the x, from minus infinity to plus infinity, I expect that to be 1 for sure. That's exactly this condition here. That integral of f of x over all possible values of x. If possible values of x go from minus infinity to plus infinity, okay, put minus infinity to plus infinity. If possible values of x go from 4 to 10, okay, put 4 to 10, that's fine. But across all possible values, then it's fine. And as we said, this will be the same as this, for example. These two probabilities are the same. If I put the equality sign here, they would be the same. If I put equality sign in both sides, they still would be the same. Only for the continuous random variables. And everything. Any questions so far, guys? Okay. Then if I give you a probability mass function, sorry, probability density function, let's say in this form. And let's assume here x changes between 0 to 3. Not from minus infinity to plus infinity or anything like that. X changes between 0 to 3. These are possible values of x. So if I want to check if this is a correct probability mass function, probability density function, then I have to make sure that f of x is greater than or equal to 0 for all possible values of x. And is this the case here? So f of x 4.13, 1 minus 1 over 16, and x to the power of 2. X varies between 0 to 3. What if we put 0?
It's still positive.
It still is positive, because if we put 0, then this multiplies by 0, and then still the whole thing is positive. What if I put 1 or 2, or let's say, what if I put 3? Then over here, what would be the number? If x is 3?
Will be 9.
9. Is this still positive? 9 over 16, 1 over 16 multiplied by 9 is 9 over 16, right? That's less than 1. So 1 minus something less than 1, for sure this part is still positive, and the whole thing is still positive. Okay, so if it's positive for the minimum and maximum, then it's positive for everything in between. And so yeah, so this condition holds. And the other condition was that I wanted f of x, integral of f of x from 0 to 3, from the lowest possible value to highest possible value, to be equal to 1. And for that, all you need to do is to just calculate the integral and making sure it is equal to 1. So, sorry, this is from 0 to 3. Okay. From 0 to 3, f of x, d of x, calculate this and check what it is. If it is equal to 1, then it is a probability mass. It's a probability mass.
In case, like the previous case, when I asked you about the
Which one?
should be 1 or I don't know. It looks like the same one when you said like from negative infinity to infinity should be 1.
Yeah. So the previous, So the previous case, I give you the f of x. This is f of x, right? And in this problem, x goes from minus infinity to plus infinity. So if I want to check this is a valid probability density function, I have to look at integral of f of x over all possible values of x, and all possible value of x here goes from minus infinity to plus infinity. However, here I'm telling you that for this probability density function, these are the possible values for x. So this random variable takes values between 0 to 3. That's the definition of random variable. Whatever it is, it takes values between 0 to 3, and this is the definition of probability density function. If you want to know this is a valid probability density function, check if it is greater than or equal to 0 for all values in this range. Also, check if the integral of this function equals to 1 for all across all possible values of x, and possible values of the random variable here is just between 0 to 3.
So when we check for it should be greater than 0, we check for the function itself, not for the integration.
No. Just yeah, exactly. Check for the function. Check for the function itself.
Thank you.
Okay, okay, so this is a valid probability mass function. Now, if I tell you, for example, calculate expected value of x, how do you do the calculation? Based on the definition, expected value of x is integral of x multiplied by f of x, right? For all possible values again, across all possible values of x. In this example, if I ask you to calculate expected value of x, is integral of x multiplied by f of x, which is across all possible values, which is from 0 to 3 here. So x multiplied by f of x, x multiplied by f of x, d of x. Calculate this integral, that gives you the average of x. If I ask you what is variance of x, how do you get that one?
Same thing, just the x squared times the function of x.
So variance is expected value of x2 minus expected value of x to the power 2, right? So expected value of x is what we already calculated here. So you know you have that. You just have to raise it to the power 2. And then expected value of x2, how do you calculate this one? Integral
from 0 to 3.
x2 multiply, exactly, from 0 to 3. Integral of x2 multiply by f of x dx. That gives you expected value of x2. And you already know expected value of x. So do the calculations to find what is variance of this random variable. Okay, so that's the formula for anything. As long as you have the f of x, probability density function of a random variable, if I ask you what is expected value of x, all you need to calculate is integral of x, f of x, over all possible value of x. And if I ask you to calculate variance of x, that's expected value of x2 minus expected value of x to the power of 2. This one, you already have it from previous section. This one, just calculate it. How? Like expected value of anything is integral of that thing multiplied by f of x. So do the calculations, put the numbers back, and find out the answer.